In lesson 4.6, we actually were working on expanding special binomial products. So for example, one of the special products we looked at is when we had a binomial with an exponent of 2 on the outside, and we said, be nice, write that out twice. And then we found that the shortcut was the square of the first, twice the product, and the square of the last. And you always use the sign from the middle. So that's really what I have over here. It's square the first, double the product, square the last, square the first, double the product, square the last. So if we see that kind of pattern happening in an example where I have something that I can square root to work backwards and something I can square root here to work backwards, there's a good chance that it's going to factor quickly as a perfect square. So to do that, to work backwards, I'm going to square root this first term. So I square root that first term, I get x, it goes at the beginning of the bracket. I'm going to square root this last term, the square root of 9 is a 3, and then I'm going to take the sign from the middle. So the sign here is a plus, and put a square on the outside. But the key is I've got to check, does it double the product? If I double the product, do I end up with this plus 6x? All right, so I just do a quick check. I'm going to have an x times a positive 3, and then I have to double that, so 2 times that. 2 times x times the positive 3 would be 6x, positive 6x, and yes, that does work. So this is the quick way to factor that. It's also a simple trinomial, so you could also treat this like adding to 6 and multiplying to positive 9. Two numbers that will multiply to 9 would be 1 and 9, and then 3 and 3. And if you check that out, the 3 and the 3 multiplies to 9 and adds to 6. So you could do decomposition, but because this is a simple trinomial with a 1 in front of the x squared, it also tells me that when I get these two numbers, I would have an x in the beginnings of my brackets to get the x squared, and then I would have a plus 3 and a plus 3. Which is really x plus 3 all to the exponent of 2. So lots of shortcuts for that particular trinomial. If we have two binomials, so I'm going back up here to the top, if I have two binomials that look the same except one has a plus and one has a minus, remember we called that the conjugate, those binomials are conjugates of one another. They look the same but have opposite signs. Those ones end up making that middle term disappear, or the middle term's actually a 0. So the quick way to factor when we have a perfect square, something we can square root, take away a perfect square, is we can square root the first and put it at the beginnings of the brackets, and we can square root the last, put it at the ends of the brackets, and make one bracket a plus and one bracket a minus. All right, so let's try that with example B. It looks like I have a difference. I'm subtracting. I can square root the x squared and get an x, and I can square root the 100 and get 10. So what I do is take the square root of the first, which will just be an x, put it at the beginnings of my brackets. I'm going to square root the last, which is going to be 10. I put that at the ends of my brackets, and then I make one a plus and one a minus. So when I expand that, what's going to happen is I'll get an x squared, a minus 10x, but then a plus 10x. The minus 10x and the plus 10x cancel each other out, and then minus 100. Another option for that, we could treat that like a trinomial, even though there's only two terms. The what we're multiplying to would be negative 100, and what we're adding to is 0 because there's 0 x's in the middle. We have 0x in here, so we're adding to 0. Well, the two numbers that will do that would be a positive 10 and a negative 10. That's a 10, positive 10 and a negative 10. So that's where our numbers here are coming in, and we can do that because that is a simple trinomial with a middle term of 0. All right, trying the next one, part C. This looks like a perfect square. I can square root it. This looks like a perfect square. I can square root it. So I can try my shortcut like I used in part A. So why not give that a whirl? See if you can use the shortcut for that one. When you try part D, you might notice up here it says, remember to common factor first if possible. If I look at this as potentially a difference of squares, This is not a perfect square. I can't square root 162 and get a nice integer answer. Likewise with 98, I can't square root 98 and get a nice integer answer. So with part D, we're going to have to common factor first. Put me on pause, see what you can do with those, and then do a check. Okay, looking at part C, if I try that as a perfect square, I'm going to square root the first, put it at the beginnings, square root the last, put it at the end, take my sign from the middle, and then I have it to the exponent of 2. And then I want to check the twice the product. Twice the product would be d times negative 6. And that 2 times d times negative 6 would be negative 12d. Yep, that worked. I can do it that way. Part D, I think if we look at a common factor out of that, I think 2 is common to both of those numbers. 98 divided by 2 is a 49. So I can take a 2 out. That would give us 49 m squared. Take away, and then 162 divided by 2 is 81. And then what I have left in the bracket is a difference, and I can square root the first and square root the last, so it is a difference of squares. Square root the first, I get 7m. That's going to go at the beginnings of the brackets. Square root the last, that's going to be a 9. Make one a plus, make one a minus. And you can check that. You can expand it and simplify it, and you should get back to the original question. Okay, try the next few questions and then I will do solutions for them. There are some cute little things that can happen with some of them, like I'm seeing ahead F will have something interesting there. Okay, in terms of patterns, what I'm noticing with this first one, there's 3 terms. I do notice I have a perfect square and a perfect square. That potentially could be a perfect square binomial. If I square root the first, you should get 2 x's. Square root the last, we get 7, take the sign from the middle, and then I check the twice the product to make sure that that is going to work. So 2 times 2x times 7, twice the product, 2 times 2 is 4, 4 times 7 is 28 with an x. And yep, that worked. Part F, I don't see a common factor, but I can square root the first and the last, and it is a difference in between, so that means I have 2 brackets that are going to look similar, but one will be a plus and one would be a minus. Square root of 16 x to the 4 would be 4. The square root of x to the 4 will be x squared. So I need a 4x squared times a 4x squared to get the 16x to the 4. And then the square root of 625 is 25. So then I would have a plus 25, and then we have a minus 25. Now, I'm not actually done with this one. If you finish there, it's not factored completely yet. In the first bracket, I have a perfect square, but then I have a plus and another perfect square. When I have a plus here, there is no way to factor that. I have to have the minus, like I do in the second bracket. So my second line of this is actually going to have the first bracket being identical to what it was, the 4x squared plus 25. But then the second bracket, do you notice I have a perfect square, take away another perfect square? It will factor as a second difference of squares. So the square root of 4x squared would be 2x. I'm going to have 2 brackets that look similar. The square root of 25 would be 5. So put that at the ends of the brackets, make one a plus, make one a minus. And now I'm done. There's nothing more I can factor in that one. That is its prime factorization. Okay, if you haven't tried G and H, you can. Put me on pause. Otherwise, I'll keep rolling along here. If I look at G, I'm seeing a difference. So 2 terms, a difference right here, a subtract sign. And then I see something I can square root in terms of the 9, but the 7 I cannot square root. So this doesn't work out quite as nicely. And this would be one where I, at this level, would say we cannot factor it. In grade 11, we will take that a step further. So I'm going to plop this in for talking about it in terms of if you choose to go on to advanced function, or not advanced functions, but functions, the 3U math course. The 3M, we don't get into the nitty-gritties of some of these, but the 3U, we push you a bit further. I can square root that first term, a 9y squared. The square root would be 3y. I can square root that and put it at the beginnings of the brackets. And then if I square root the last, the square root of x squared would just be x, and the square root of 7 I'm going to leave as its exact value of square root 7. So square root 7, and then the x is on the outside. It's not underneath the square root sign. And then we can make 1 plus and 1 minus. All right, so I won't give you one with a number that doesn't have a nice perfect square to it. Sometimes you will have to common factor to make that there. I certainly could give you ones with x squareds and y squareds to be able to work with, but that 7 I would probably make that like a 49 or a 25 or 36 or something like that where I can work with it further. All right, the last one's kind of another pusher. It's tricky. Do you see I have a difference right here? And then the first thing is something to the exponent of 2 and something to the exponent of 2. I could expand and simplify this and then factor it like a trinomial, or I could recognize this as a difference being the subtract, of two perfect squares, just like I had in question F, a difference of two perfect squares. So here's what this looks like. I'm going to put my equal sign over here so I have lots of room. I'm going to have two brackets that are going to look similar, but one will have a plus and one will have a minus. And if I square root x plus 1 to the exponent of 2, the square root will cancel out that exponent of 2, leaving me with an x plus 1. So that's what's going to go at the beginnings of my brackets. I get an x plus 1 at the beginnings of my brackets. That's the square root of that part. At the end of the bracket, I would have the square root of this last term here. This is 2x minus 3 all to the exponent of 2. When I square root that, that's going to undo the exponent of 2, leaving me with a 2x minus 3 at the ends of my brackets. And then I make one a plus, and I make one a minus. But then I have to actually tidy this up. I have to make it look nicer. I really just have a 1 times that first bracket. So 1 times x plus 1 would just be an x plus 1. And to it I'm adding 1 times my second bracket, so I would have plus 2x minus 3. And then the second big set of brackets, I would have 1 times the x plus 1, which is x plus 1. And then I have a takeaway. I'm going to take away everything in this second bracket. It would be take away 2x, add 3. And now I'm going to tidy further by collecting like terms. I have x plus 2 more x's would be 3 x's. So then 3 x's, and I have a plus 1 and a minus 3 would be minus 2. So this first big square bracket I could reduce down to 3x minus 2. That's supposed to just be, whoops, it's supposed to just be a bracket there. Whoops, minus 2, bracket. And then the second set of big brackets, I have an x minus 2x, which would be a minus x. And then we have a plus 1 plus 3, which is plus 4. Okay, so if you factor it by expanding, simplifying first, getting your regular trinomial there, and then doing your trinomial factoring, you should get those as your two brackets. Just another way to do that question.